Till now, we have already covered what is the area of a circle, what is the area of a semicircle, what is the area of a quadrant. Okay. Now we were discussing questions. Okay, and this is the last question of this exercise. There will be many questions, but one such type of question. Okay, that you can have in your exercise. Okay. Now here's the question: the short and long. Okay. Now what does the question says? The short and long hands of a clock are. Okay. Now, as it is talking about the clock, so let's see, this is your clock. Okay, and everybody knows that there are two hands of a clock. Okay, one is the small hand and one is the bigger one. Which color are you? Okay, so you can say that there will be two circles for here. Okay, now the short and long hands of a clock are 6 centimeter and 8 centimeter. Now the values here are, this one is 6 centimeter and this one is 8 centimeter. Okay, long respectively. Find the sum of the distance traveled by the tip in one day. First of all, distance traveled by the tip. Okay, distance traveled by the tip means the circumference. Okay, now the sum of the distance. The sum of the distance means you have to find the circumference of the smaller circle also, the 6 centimeter radius circle also, and the circumference of the bigger circle also. Okay, now this will be the distance for one revolution. Okay, one revolution means that both the hands of the clock make many revolution. Okay, because it is asking you in one day. So in one there are two hands. Okay, now this hand represent the market. Now this hand represent what? Our hand. Our hand. The smaller one represent the hour. Okay, and it means hour means how many revolution or how many rotation that will make in a one day. That will be 24, because there are 24 hours in a day. So 24 times this small hand of the clock will move. Okay, make revolution. Okay, full circumference will become, so 20, whatever is the circumference of the smaller circle, you'll have to multiply with 24. Okay, because 24 times it is that tip of that smaller hand is going to make a circle. Okay, now if we are talking about this is a minute hand. Minute hand is going to move how many times in 1 hour? In 1 hour it is going to move, or you can say hour. There are 24 hours, and in 1 hour you have 60 minutes. Yes, so how many revolution this bigger one will make?
1440.
Yeah, wait, that's why just see, this is what? This is your hour hand. Okay, oh shit. Okay, yes, I got confused. Okay, this is your hour hand. Okay, now how many revolution it is going to make? You have for 12 hour. 12 is already marked here. Okay, 12, 3, 6, 9. Okay, there are 12 hours. Okay, so for 12 hours, this small hour hand is going to make only one revolution. Yes, and in a one day is equal to 24 hours. Yes or no? Okay, so one round of a clock covers 12 hours. Yes, one round of small hand is equal to 12 hours. Yes, we need to cover 24 hours. So one day में आपका 2 into, you'll have the small hand will make 2 revolutions. Okay, how many revolutions small hand will make? Number of revolutions made by small hand is equal to 2. Okay, so area, your circumference, no? Circumference covered by small hand in one day is equal to 2 pi r. Okay, so 2 pi 22 by 7, r is 6. Okay, yes, multiplied by 2. Okay, understood why again 2? 2 is for number of times. Okay, now similarly, number of rotation, highlight color option made by big hand. Now how many revolution big hand will make? 24, because 24 hour is there, and in 1 hour it will make the complete circle. Yes or no?
Yes.
Okay, I got confused and I wrote there, and that's why I was. Okay, now circumference covered, not circumference, you write distance covered. So circumference covered will be Only one. Distance covered. Distance by big hand. How much distance will be covered? Again 2 pi r to 2. And what is it? How much is the 8 centimeter into 24? Okay. Now we need to find the sum of the distance. Yes. So therefore, sum of distance traveled by tip of both hand in one day is equal to 2 into 22 by 7 into 6 into 2 plus 2 into 22 by 7 into 8 into 24. Okay. Now you can take out common. 2 into 22 by 7. 2 pi you can take common. So 12 plus. Okay. After solving this, you'll get the answer. Okay. Now what answer I've written here? 1282.29 centimeter approx. That is the distance that is covered. Any doubt in this question? Any confusion? Okay. Don't get confused like I got confused. Okay. Safia, any doubt? Rudoniel, if you have any doubt, you may ask. Good. Now we are going to start with another section. Area of sector and segment. Just a minute. Area of sector and segment. Okay. Till now we have covered the area of circle. Okay. And then we have covered area of semicircle and then quadrant. Now we are going to cover sector. Now, what is a sector? This is also a part of a circle, but this is distance. This is this part of the circle. This is called the segment. Sorry, sector, not segment. Segment is between the chord and this is sector. Now you can see if I'm calling it sector. Sector is the distance. Sector is the area between the two radius and the arc. Okay, the two radius and the arc. Now this one, this is also a sector, you can say, because this is also, this area is also between two radius, this radius and this radius and the arc. Okay, but you can see here this is the smaller arc, so we call it minor sector, and this one major sector. Okay, if it is not mentioned in your question that which sector, so you will always opt for the minor sector. Okay, if it is mentioned for minor sector or major sector, then only will go. If it is not mentioned, always go for minor sector. Okay. Now the angle that is made at the center, this is called the angle of the sector. Okay. Now important points to remember. And yeah, this is more important, that the angle of minor sector is less than 180 degree and angle of major sector is more than 180 degree. Okay. And the sum of the angles of major sector and minor sector, because we already know that the angle that the circle make at the center is 360 degree. Okay. The sum of arc of major and minor sector of a circle is equal to the circumference. Okay. Now, if you just see the arc, okay, this is your arc that the minor sector make, and this is the arc that the major sector make. Okay. If you are going to add both the arc of the major sector and the minor sector, that then it will be equal to the circumference of the circle, the complete circle. Okay. The sum of the area of the major sector, obviously the sum of the area, if you're going to add the area of both the minor sector and the major sector, that will give you the area of the complete sector. Or if you can say, if it is in the question, it is already given the area of the minor sector, then you can add the radius. Okay. So then what you can do, you can find the area of the complete sector, complete circle, because that is the easier one. Okay. And then you can subtract the area of the minor sector to get the area of the major sector. Or in the question, if it is given the area of the major sector and the radius, then you can find the area of the complete circle and subtract the major sector to get the area of the minor sector. Any doubt in this? Now, what is the area of a sector? Okay, because we need to find out the area of the sector, because it's not necessary that in the question it is always given the area of major sector or minor sector. Okay, you need to find out the area of the sector also. Okay, so area of the sector here, because this is not a quadrant also. Okay, it can form a quadrant, but it's not necessary. Okay, so here the area of the sector is equal to theta, the angle that the sector make at the center, upon the complete angle that does in the center. Okay, multiplied by pi r square. Okay, we are talking about the area of the sector. Area of the circle is the pi r square. Now, how we are taking out? We just need this portion area. Okay, so we are finding out the angle Okay, okay, that much angle area we are going to multiply it with that. Okay, so theta, the angle that the sector make at the center, okay, whatever angle, 30 degree, 40 degree, 60 degree, 80 degree, okay, 90 degree, and then divide by 360. Now if you get the theta value as 90 degree, okay, so you can directly apply for chord, okay, sorry, directly apply for quadrant, okay, because it will form a quadrant. Okay, now that I already explained you that the area of major sector is equal to the complete area of the circle minus area of the minor sector. Area of minor sector is equal to area of complete sector, complete circle minus area of the major sector. Okay, understood? Any doubt here? No. Okay, as I already told you that theta will be for sector, it is generally less than 180 degree. For minor sector and for major sector it is greater than 180 degree. But if theta is equal to 90 degree, so you already know that it will be a quadrant, because the quadrant holds the angle in the center as 90 degree. Okay, and the semicircle holds the angle of 180 degree. Okay, so if theta value is equal to 180 degrees, so that is a semicircle, and then you can find the area as half pi r square. Okay, and if the theta is 90 degree, then you can find the area as 1/4 pi r square. Actually, this is also following the same formula. Okay, 90 degree upon 360 degree. Okay, you will get what? 1/4. 180 degree upon 360 degree. What you will get? 1/2. Yes, we are actually calculating by this theta upon 360 that what part of the circle we are, how much part of the circle area we need to find out. Okay, 30 डिग्री का एरिया निकालना है, 40 डिग्री का निकालना है, कितने एरिया सर्कल की कितने पार्ट का एरिया निकालना है, that it means. Okay, this much part or this much part or this much part or this much part or this much part. Okay, so theta upon 360 into pi r square. In fact, if you remember this main formula, theta upon 360 degree into pi r square for the area of the circle, that will help you more. Okay, why? Because whatever is your degree, okay, if you are finding out the area of the complete circle, 360 upon 360, that will give you 1, that is only pi r square. If the area of the if you're finding of semicircle, so it will be 180 upon 360, 1/2 into pi r square. If you're finding upon quadrant, 90 upon 360, that will give you 1/4 into pi r square. And for any other angle also it will work. Okay, so this you can remember as a main formula. Okay, theta upon 360, because this formula will work in any condition. Okay, for any degree of your circle. Okay, whatever is the degree. So this is your very important formula. Now let's see one of the question, and then we will see the circumference. Circumference means the arc, how much arc is covered. Okay, okay. The length of the, okay, what is the question here? The length of minute hand of a clock is 14 centimeter. Minute hand, okay. This is your clock. This is your minute hand. Okay, minute hand is bigger. It is 14 centimeter. Find the area swept by the minute hand in 1 minute. Okay, now in 1 minute, how much area is the minute hand will cover? Okay, now when the minute hand is actually moving, making the complete revolution, so in 1 revolution.
Hello ma'am, good evening ma'am. I was having my test, that's why I joined late.
Okay, fine, no problem, Shazan. Okay, so in 1 revolution, we are just going through the question. Okay, yeah, in 1 revolution 60 minutes are there. Yes, am I right? In 1 revolution 60 minutes are there, and we are talking about only in 1 minute. In 1 minute, what area is length of the minute hand? The area swept by the minute hand in 1 minute only. Okay, so how can you find out? Okay, the complete circle is of what? 360. Okay, first of all, we need to find out the theta. This theta we need to find out. Okay, now how can we find out this theta? Okay, let's see. 1 minute, in 1 minute, angle in the angle that in 1 minute it will be covered, that is 360 is your complete angle. The angle is 60 degree. Okay, and 60 degree, not 60 degree, it will be 60 minutes are there. Okay, so it will be equal to what? 6 6 degree will be the value of theta in 1 minute. Okay, the value of theta in 1 minute will be 6 degree. Okay, understood? Now, so the area swept by in 1 minute will be equal to what? Theta upon 360 degree into pi r square. Now, Shazan, this is your formula I just discussed. Okay, that for any degree, whatever angle, actually we discuss about sector first. Okay, for all the circle. Okay, for any part of the circle, if you're finding out the area, so this formula is going to work, where theta is the angle that it is making at the center, upon 360 is the complete angle of a circle, upon pi r square. Okay, so this is your, it will work for all the, whenever you're finding out circle or any part of the area of any part of the circle. Okay, so theta upon 360. Now, what is the value of theta? We have already find out, that is 6 degree. 6 upon 360 degree into pi r square. 22 by 7 it is mentioned, so we have to take 22 by 7 into 14 pi r square, so 14 two times. Okay, now 1 upon 60 into 22 by 7 into 14. Now you need to solve this and you will get the answer. Okay, understood this question? Any doubt? If it will be see, we have already find out for 1 minute. So similarly, you can find out for any minute. Okay, like if it is asking you about 10 minutes. Okay, so we have already find out for 1 minute. Okay, like unitary method, how we do the unitary method. Okay, for 1 minute we have find out. So you're just going to, if you need to find out for 10 minutes, what is the area covered by the minute hand in 10 minutes. So 6 into 10, that will be 60. Okay, similarly you are going to. Any doubt in the question? Shazan, do you have any doubt? Because you joined a little late. Now, let's see the length of an arc. Okay. Now, we generally, when we're talking about the length of the circle, then we don't call the length of the circle. Okay. We call it the circumference. But here we are saying the length of an arc, because in arc, only part of your circumference is there. Okay. Either you are taking the minor arc or the major arc Okay. If any of the arc you are taking, it is just a part of your circumference. Okay, so we are talking about, we are saying as length, which is we are taking at length. Okay, now what is the length of the arc of the circle? Again, the same formula, theta upon 360 degree, but this time you are finding out the circumference. Okay, the length. So it will not be pi r square, it will be 2 pi r, okay, which is the circumference of your complete circle. Okay, theta upon 360 degree into 2 pi r. Okay, whatever is the degree, if the degree, and yeah, if the degree is 180 degree, so it will be for semicircle. Okay, again, you'll get the pi r. Okay, and if it is theta is equal to 90 degree, it will be a quadrant. Okay, and if theta is any other, that for that particular angle, you are going to find out the part of the circumference. Okay, now similarly, now area of sector in terms of length. Okay, now we have seen the area of the arc, area of the sector. Okay, now if we are taking area of the sector in terms of length, in terms of this arc. Okay, so what can we write? Half LR. Okay, and here if your L is given, that is fine. If in the question your length of the arc is already given, then it is okay. Else you follow this formula. Else you will follow the theta upon 360 into pi r. Okay, if the length is given, so you will follow this directly. You can find out with this formula, half LR. Okay, where L value is equal to this. Any doubt in the length of an arc of a sector? No. Okay, now let's see the question. I think this is your easiest chapter. Yes. Now, in a circle of radius 28 centimeter. So here the radius is 28 centimeter and arc subtended an angle of 45 degrees. Okay, so what is the radius? 28 centimeter and arc subtend an angle of 45 degree. So this is your 45 degree. At the center, find the length of the arc and using it, find the area of the sector. Now, here we have to find the length of the arc. Okay, this we have to find. Okay, so what will be the length of the arc? Length of arc is equal to theta upon 360 degree into 2 pi r. Okay, so theta is already given, that is 45 degree upon 360 degree into 2 into 22 by 7 into r is 28. Okay, so if you are going to cancel 1 upon 8, 22 centimeter. Okay, now you have to use the same length to find out. It is given, find the area of the sector by using the same length. Now, what is the area of the sector? Length half LR. Okay, area of sector will be equal to half L into R. Okay, half L value we have already find out, and R is 28. Okay, 11 into 28 centimeters. Any doubt? Vidoniel, Safia, Shazan, any doubt? So we have covered the area of the sector. Okay, now let's see the another part, that is area of the segment, or you can say segment of the circle. In sector, we have covered both the circumference and the arc. Okay, we cannot say circumference because circumference is for the complete circle, and in sector we just cover the arc. Okay, a part of the circumference only. Okay, so we have already seen how to find out the length, that is what is the length of the length of the arc and the area of the complete sector, and we've also seen the area of the sector in terms of the length of the sector. Okay, now let's come to segment of a circle. Now, what is the segment? This portion is the segment. This shaded portion is the segment. Okay, understood? So you can say that if you need to find out the area of the segment, so you can find out the area of the sector minus the area of the triangle AOB. Then you will get the area of the segment, that is APB. Okay, so area of this means the segment. Segment is what portion? Segment is the area between the chord and the arc. Okay, the chord and the arc. Here it is written, the region bounded by a chord and the corresponding arc of the circle is called the segment of the circle. Okay, so this one is the minor segment. If I am talking about the major segment, the whole above portion is the major segment. This whole above portion is the major segment. This still here. Okay, because it is the region between the chord and the arc arc. Okay, okay, chord and the arc. Now here you can see one is the smaller one is the minor segment. Okay, because chord is going to divide the circle into two parts. Okay, so if we are considering chord, the distance, the area between the chord and the arc, so between the chord and the arc there are two types of area. Okay, one is the smaller portion, okay, that you can say APB, that is the minor segment. Okay, and the bigger one ADB, that is the major. In fact, you can say OADB, that is the major segment. Okay, now here what is the area of the segment? Obviously we can see you can directly just find out the area of the segment. What we are going to do, we have to find the area of the corresponding sector. Okay, the area of the sector, and we are going to subtract the area of the triangle that is formed with the chord and the two radius. Okay, then we'll get the area of the segment. Okay, now again, if you know one of the area of the segment, that is if you know the area of the major segment, then you can subtract the area of the minor. If you know the area of the major segment, then you can find out the area of minor segment by subtracting the area of major segment from the complete area of the circle. Okay, and if you know the area of the minor segment, then you can find the area of the major segment by subtracting the area of the minor segment from the area of the complete circle. Okay, any doubt in any of this?
No, ma'am.
And yeah, this I have already told you. That whenever we have just written the segment or sector, any one of this, then you are always going to refer the minor one. Okay, until and unless it is mentioned that you have to go for major one. Okay, अगर mention नहीं है कि आपको major segment का area निकालना है, major segment का length निकालना है, till then you are going to go for minor. Okay, so by default, what we say like default na, so by default it is minor. Okay, unless and until it is mentioned to go for minor or for major. Okay, so you always have to go for the minor. Now I think this is the last. After this, we are going to, this is the last question. We are going to complete the chapter. Okay, so after that, you can go with the next chapter. The next chapter will be, I think, surface area and volume we will be starting. Yes, I think.
Mom, can we do AP next? Arithmetic progression.
You want to go with arithmetic progression? Okay,
Yes,
fine. Okay, we'll do with arithmetic progression. Okay. But before that, you will be having your test. Okay, because we have completed the chapter. So, and I think we have done circle assignment only. Yes, we have not started with the this area of circle assignment. Okay.
Yes, Mom. Can we do some assignment first, and then you can take the test?
Okay, what we can do in the next class, I can assign you in both the classes, in the teaching class, and that also we are going to do assignment. We'll discuss maximum question. Okay, and then we are going to have the test on next Tuesday. Is that okay?
Yes, Mom.
Okay, so we are going to discuss both the assignment. I'll assign you both the assignment. Okay, the on the first question. Okay, also where we have discussed the area of the circle, semicircle, and quadrant, and this question also the area of sector and segment, and I will be discussing maximum question. Okay, I'll giving you time also, you can also do, and we will discuss the maximum question, and then on Tuesday we'll be having a test. Okay, so in that way you will cover the questions also, and you will not be having doubt. Find the area of the segment AYB. Okay, let me copy this text. Okay, find the area of the segment AYB. AYB. Okay, this area you have to find out. Okay, because we have to find out the area of the segment. If radius of the circle is 28 centimeter and angle AOB is equal to 90 degree. Okay, angle AOB is equal to 90 degree. That means it is a quadrant. Okay, that whole question is a quadrant. Okay, now how we are going to find the area of the segment? First of all, we need to find out the area of the sector. Yes, that is the way to find out. So area of sector OAYB. Okay, that will be, you can see it is a quadrant, it is 90 degrees, so it will be 1/4 into, or if you are going to apply the formula also, 90 degree upon 360 degree, that will also give you 1/4 into 22/7. It is written pi value 22/7 pi r square 28 into 28. Okay, understood? So that is the area of the sector. Okay, so now if we are going to find out the area of the triangle, how we are going to find out the area of the triangle?
Is half into base into height.
Yeah, you need to find out the base area. Okay, or what you can, Shazan, do you remember the area of an isosceles triangle?
Yes, ma'am, it was root 3/4 a square.
Root 3/4
A square.
I think that's for an equilateral triangle.
Yes, it's for equilateral.
No, you are not correct.
Since this is a right triangle, we can do half into 28 into 28.
Okay, I'm just telling you because see, both will be always radius. Whenever you are finding out this triangle area, both of them will be always radius. So it will always.
It's half base height. There's a right angle triangle.
Isosceles triangle area is triangle area A root 4 B square minus. But wait, you need to have this A also, na? Here you don't have A. Okay, don't apply it. We are going to find out half base into height. If you know the third one, then only you can find out the area. Else it will be little, you cannot find out. Okay, so obviously we know that it is a 90 degree. Okay, and we are going to make a perpendicular from here. We are going to make a perpendicular. Okay, this height is the perpendicular distance from the from one of the tip. Okay, so what will be this? You can say what will be the height of this perpendicular. In fact, you can apply trigonometry here. Yes, see, if we are going to draw perpendicular, so we can take this angle as 45 degree. Yes or no? Everybody, can we take it 45 or not?
Yes.
Okay, and this actually, why we can apply the trigonometry, that this angle will be 90 degree because we are drawing the perpendicular. Okay, a right angle triangle, you apply trigonometry, na? So this angle will be 45 degree. Now we need to find the base, this portion. Okay, we need to find this. So if this angle is there, so according corresponding to this angle, this will be what? Perpendicular. Yeah, perpendicular, and this will be base. Okay, so we are going to apply cos 45 degree. Cos 45 degree. Cos 45 degree will be what?
It will be 1 by root 2.
Oh, you can mention here OP. OP upon hypotenuse. Okay, that will be 28 degree. Okay. Yeah, and cos 45 degree value is what? Sin 45 and cos 45 is 1 by root 2. So we'll get 1 by root 2 is equal to OP upon 28. So which implies that OP value will be equal to 28 upon root 2. Okay. Okay, so we got OP value. Base into height we need now. So we need the value of base also now. We need this also. Sorry, we have just find out the height value. Okay, this OP is height. So we have find out the value of OP. Now we need to find out the value of AP also. Actually, AP का आपको 2 times करना होगा. Okay, first you have to now find out AP, and similarly BP will be the same value. Okay. So let's find out the value of AP. So for finding out the value of AP, we need to go with sine 45 degree. Okay, sine 45 degree will be equal to AP upon 28. Okay, so that will imply sine 45 is also 1 by root 2 equal to AP upon 28. AP value will be again 28 upon root 2. Yes or no? So now base value, base is equal to AB. Okay, so AB is equal to 2AP. Okay, which is equal to 2 into 28 upon root 2. Okay, so what you will get? You will get the value as 28 root 2 centimeter. Okay, now area of triangle OAB will be equal to half base. Base is what? AB, and OP is your height, na? OP is your half base into height. Okay, so half into what we got, 28 by root 2, 28 upon root 2 multiplied by 28 into root 2. Yes, so root 2 cancel, and one of the 28 will also get cancelled, and then you will get the value as 392 centimeter square. Okay, now this is your triangle area. Now we need to find out the segment. Area of segment is equal to area of sector is what? How much we have find out the area of sector? Okay, I have not find out the area of the sector. Okay, this is your area of the segment. Okay, minus. Okay, so if you are going to subtract, it will be 4. Any doubt?